Hello folks, today we are going to see the Newton's law, the first and second law of Newton. So the first law, in other words, in simple words, if the body is at rest, it stays at rest. If it is moving, it continues to move with the same velocity, same magnitude and same direction. So we use to it inertial frame. You use an inertial frame to the first law to be true. Okay, for a person, for example, you use the earth. You know that we have rotation, but we measure assume that the ground is an inertial frame, okay, to measure the forces according to this frame. Okay, if you think about it, the person and the earth are in the same velocity, and because it we have the first law as a true. Okay, we have here a representation of force. We will add all the forces that are acting in a body, like this bar here. Okay, and we have the add of these forces here, and we will add it. Okay, this fact is called the principle of superposition of force. We will add it. Okay, let's go to see how it works. In an example here, we have this Newton's second law. There is net force is mass multiplied by acceleration. It's a vector. Okay, we will add, we will sum all the net force in the x-axis, in y, and in z here to find the net force here. Okay, and we have this quantity Newton. We call Newton kilograms multiplied by meters for square seconds. Okay, squared seconds. So we have here the Newton. It's a unit of measure to force. So let's go to see this solved example. The first is just to multiply the mass by the acceleration. We have two more here. I'm sorry about it. So we have 4 newtons. We have here a college notation of vectors. Okay, vector notation. So we have here the solved example 2. We have here, you need to add these two in the letter E. What is the resultant? Net for the net force is the resultant of these two vectors. We will add in x and in y using this vector notation. We have here classes about the vector notation. Okay, in the letter B, find the magnitude. You know that to find the magnitude you use these ideas. We have here a lesson about vectors too. So we will need to find the direction. What is the angle here? We will use tangent to solve, and we have here this picture, and we have almost 46 degrees. Let's go to do some exercise. Now you can stop and I will solve it. Okay, I will solve. So we have here just mass multiplied by acceleration, and we will find this acceleration. In the letter 2, we have F1 9 newtons, and we have F2 8 newtons with this angle of 62 degrees, and we will find the force here in X to find, and we have plus here in minus here, using just the idea of x axis here. Here is positive and here is negative, and we have the resultant force here. Let's go to see more other exercise. Stop now and do. Okay, I will do. Here is just to add vectors. Okay, you will adding the vectors. Okay, adding each vector and finding the acceleration in the final. This is the idea. Stop now, you can do it. Okay, let's go to do. Okay, we find the force in x and the force in y, and put it in a vector notation as the exercise asked for.